Why do people weigh less at the equator than they would if they were at the poles? Well, here's one answer. The Earth bulges at the equator. Therefore, the distance between the mass centers is greater, so the force is less. This is from Newton's law of gravity. Because the Earth bulges a bit at the center, if you're at the equator, your center of mass and the Earth's center of mass are a little farther apart than those centers of mass would be if you were at the poles. And so, in the denominator of Newton's law of gravity, if r is relatively big, then the force of gravity is going to be relatively smaller. And that is one answer. A second answer is that Earth spins. Now, what does that have to do with why people weigh less? Here's the axis of the Earth, which I know is inclined at 23.5 degrees, but I've drawn it straight up just so we can see it a little bit better here. And across the middle here, there's the equator. At the equator, I'm going to put a bathroom scale right there. And we're going to start spinning this planet. So this is a thought experiment. And we're going to Velcro this bathroom scale to the Earth so it doesn't fall off. If the Earth is not spinning, we have a certain weight. We read it off the scale, we write that number down. Now, as we start to spin the planet, can you see that as we spin this, you have a tendency to want to fly off. The faster we spin it, the more you want to fly off. And if we spun it fast enough, you would fly off, and the bathroom scale would read 0. So, the faster we spin this thing, the lower the reading on the scale. And like I said, if we spun it fast enough, you would completely fly off the planet, because the bathroom scale is velcroed to the planet, and you aren't. And if we spun the Earth fast enough, you would fly off. The bathroom scale would read 0. So clearly, as the Earth spins, you weigh a little bit less. The faster the Earth spins, the lower the scale reads. If Earth spins fast enough, the scale reads 0. Let's take another approach at this. We've got the Earth and the Moon. The Earth pulls on the Moon with a force due to the gravitational interaction between the Earth and the Moon. Of course, the Moon pulls on the Earth too, but I'm not showing that force. I'm just showing the force with which the Earth pulls on the Moon. The Moon travels in nearly a circle around the Earth, so there is a centripetal force that's needed to keep the Moon moving in a circle. And the apparent weight of the Moon is 0. If we were to put a scale on the Earth and ask, what does the Moon weigh? The apparent weight of the Moon is 0. In other words, the apparent weight of any object that is going around the Earth is the force of gravity on the object minus the centripetal force, the force needed to keep that object moving in a circle. Now, let's look at a 71 kilogram mass, which is roughly my mass. On Earth's surface, the Earth pulls on a 71 kilogram mass with a force of 696.5 newtons. If I'm at the equator, there is a certain force that's required to keep me in a circle. And that force, there's an equation for centripetal force. There's my mass, 71 kilograms. There's the radius of the Earth, 6.38 times 10 to the 6th. You can look that up. The angular velocity is angular displacement, which is 2 pi radians. That's one time around every 24 hours. That's what's in this denominator here. And then I've changed it into seconds by multiplying by 3600. So I'm trying to save space on the slide here. This is radians per second, and of course we've got to square that quantity because that's what it has in the equation. And that number comes out to be 2.4 newtons. In other words, of the 696.5 newtons that the Earth pulls on me, when I'm at the equator, 2.4 of those newtons are required just to keep me moving in a circle with the planet at the equator. Those 2.4 newtons are not read by the scale. Now the other newtons are read by the scale. If I step on a scale at the equator with the Earth not rotating, the scale would read, if it were reading in newtons, 696.5 newtons. But since the Earth is rotating, when I step on that same scale with the rotating Earth, the scale only reads 694.1.